We are at the European Space Agency, but more precisely in the biggest center of the European Space Agency. Is located in Norwich, Holland, and it is the so-called ESTEC, is the technical center. So basically it is here where most of the technical expertise is for designing, developing the satellites. In fact, we do it together with the European Industries Research Centers, not just alone. In fact, they do most of the work, but the satellites are also tested here, so we have a very big test center. And we have also technology laboratories. In particular, now we are in the solar generator laboratories. And you know that spacecraft are powered by solar cells. Nowadays, solar cells are also widely used on Earth, but the first solar cells have been developed for space, and they still now are the most important source of energy for the spacecraft. So for the spacecraft themselves and for the all apparatus payloads that are on board the spacecraft. All in the field of electrical engineering. That means power, that means data handling, so onboard computer and transmission of data. That means electromagnetics, so antennas, the space environment, and that means control, in-orbit control, and also radio frequency payloads and navigation. The solar cell is basically a piece of material, semiconductor, that transforms the light, in this case of the sun, into electrical power. So the sun heats this special piece of hardware that I think maybe you can see here, or we can show here. Here we have an example. It's around 8 centimeters by 4, I think, and transforms. So this energy is transformed into electrical energy. So a current comes out of it. So if you have several of these mounted in series and several of these strings in parallel, you have solar panels, and you can get quite a power from there when these panels are hit by the light of the sun. These days that we have the, we have the Rosetta mission, that spacecraft that is very close to a comet and is analyzing the nucleus of the comet. It's a very, very special mission. And this brings to think back in the 90s, basically from the beginning to the 90s until the launch of Rosetta in 2004, I've been developing special solar cells for that mission that would be able to cope with a sun intensity and illumination that is much lower than what we normally have on Earth, because this spacecraft went to 5 times the distance from the Earth to the sun, and this means that the illumination was 70 times less than what we have on Earth. So it was necessary, with the help of several industries and research centers, to develop special cells. And you can imagine the satisfaction when these cells have been enabling for a mission like Rosetta. This is the first time in general that a mission like that is powered with solar cells and not with nuclear. So it's a very big satisfaction, and I'm sure whoever you ask around can tell you a story like that, of something where he or she put a lot of effort, a lot of knowledge, and in the end see the results. It's really satisfying.